This is the Dinglun Flywheel Energy Storage Power Station. At 30 megawatts, this is likely the biggest flywheel energy storage system on the planet. But don't let that spin you around though. While its sheer size is unrivaled, it's not alone. More and more people are turning to mechanical energy storage systems like flywheels as the solution to large-scale energy woes. So why the sudden uptick of interest in this otherwise niche mechanical energy storage device? And can a spinning wheel really compete with lithium batteries and all the other energy storage systems that are available to us? I'm Ferrell. Welcome to Undecided. This video is brought to you by Incogni. We took a spin at this topic almost 4 years ago now, and there's been a lot of movement with flywheels since then. Now, California-based Amber Kinetics has been rolling out installations, and as I just mentioned, China has brought one of the largest systems online recently. But in case you aren't familiar, what is a flywheel? Or more accurately, what is a flywheel energy storage system, or FESS? It's essentially a mechanical battery made by combining a dual-action electric motor and a big, heavy, wheel. You can charge an FESS by using excess electricity to spin up the flywheel. Once it's spinning, it wants to keep spinning, meaning only a little electricity is needed to maintain its speed. Then when electrical energy is needed, the flywheel's inertia is used to turn a generator. Then the wheels spin the generator's rotor and voila, electricity. Sort of like a regenerative braking in an electric vehicle. This makes for a very efficient mechanical battery. Flywheels have a unique edge in energy storage, and that advantage becomes even clearer as we dive into their perks. But before we get into the latest breakthroughs, here's the big question. Why choose a flywheel over a chemical battery? Now, understanding this is key to seeing why flywheels are really picking up speed. Flywheels are especially valuable for pairing with renewables like wind and solar, which have variable output due to shifting conditions. For example, wind turbines produce more power in high winds and none when still, leading to inconsistent power output or amplitude. A major advantage of flywheels is the rotational inertia. As heavy, fast-spinning devices, they can store and release energy quickly, stabilizing the grid during short-term power fluctuations. This inertia is crucial for grid stability, especially with renewables that don't provide constant output. While most power generation, including renewables with inverters, needs to carefully control frequency to deliver standard 60 Hz AC in the US or 50 Hz elsewhere, flywheels help with this by operating at a steady speed, minimizing conversion losses. Though flywheels can spin at extremely high speeds, up to 50,000 RPM, their mechanical inertia primarily addresses amplitude fluctuations, making them a steady partner for renewables. And the rotational speed can be adjusted during spin-up and generation modes, resulting in less energy loss to heat. Plus, their ability to charge and discharge at supercapacitor speeds makes them incredibly responsive. This quick responsiveness is invaluable for patching over grid dips and absorbing extra power during spikes. It's also handy in emergencies. Another FESS perk is its high round-trip efficiency, or RTE. That's the percentage of stored electricity that can be retrieved, and no system has a perfect RTE. Energy is always lost in the transfer between mediums, and flywheels do lose more energy over time than chemical batteries. But as long as you're not storing that energy for extended periods, a flywheel can achieve an RTE of 90 to 95%. That's better than pumped hydro or industrial-scale batteries, which reach about 80%. This efficiency makes FESSs an excellent fit with renewables. Flywheels offer other advantages too. Their simplicity means they often last 30 years or more. And unlike batteries, they don't rely on chemical storage, so they can handle tens of thousands of full cycles without degradation. They also don't require rare earth metals, and the most advanced flywheels are often made from carbon fiber, which, while not cheap at around $7 per pound, has dropped significantly from $15 just a few years ago and is expected to continue falling as production becomes more widespread. At this point, you might be wondering, why aren't flywheels everywhere? I've hinted at some of the reasons why FESSs remain niche, but there's something else that's not limited to a niche, and it's a big problem. Have you ever been deluged by random promotional emails and messages from companies you've never heard of? Well, today's sponsor, Incogni, can help get to the source of that problem and restore some of your privacy. As my wife and I were getting our house constructed, setting up loans, getting insurance, and everything else that you have to do with moving, I saw a major uptick in the amount of spam and promotional emails I was getting. I'm sure you've experienced this kind of thing too. That happened because companies sold my information to data brokers. Sometimes they sell your info to some pretty shady people. Incogni can help you with this. We have the right to request that data brokers delete our information, but it takes a lot of time and effort. I signed up for Incogni, gave them the legal right to work on my behalf, and then just sat back and relaxed. You'll see updates in your account for which data brokers they've sent legal requests to and which ones have complied. It couldn't be easier. If you want to take back some of the control around who has access to your personal information, give Incogni a try. Take your personal data back with Incogni. Use code Undecided at the link below and get 60% off an annual plan. Thanks to Incogni and to all of you for supporting the channel. So back to why flywheels aren't everywhere. If you've been wondering how a spinning wheel can store energy without eventually slowing down to a stop, wonder no more, because it can't. There's still friction between the wheel and the generator, air resistance on the wheel, and many other points where energy converts to heat. Some flywheels are built in a vacuum chamber to reduce air resistance, and others use magnetic bearings to float the wheel instead of letting it drag on the ball bearings. Even so, Newton's first law is unforgiving. Even a perfectly lubricated, magnetically levitated flywheel with literal tons of inertia in a low friction vacuum will eventually slow down. Magnetic losses from eddy currents also slow the wheel, and these losses grow with rotational speed. Without maintenance, flywheels tend to last about 15 minutes, limiting them to very short-term applications. This also means flywheels have fast self-discharge rates compared to chemical batteries, losing about 5 to 20% of their energy per hour. At that rate, stored power could be gone in under a day, so using flywheels for long-term energy storage is a no-go. Then there's the cost. Flywheels are still quite expensive despite their overall cost efficiency. Sure, you can have functional FESSs without extras like magnetic bearings, a vacuum chamber, or a high-tensile rotor. Just look at their use in the Swiss gyro bus, often cited in flywheel discussions, including my own. But for grid-scale systems, optimization is crucial, requiring specialized materials, precision machining, and price tags that reflect those demands. And surprisingly, the lowest tech part of the flywheel system is often the most expensive: the well. Flywheels are typically buried for a good reason. They're massive, heavy components spinning up to 50,000 RPM. They're practically trying to tear themselves apart. If anything goes wrong, you don't want chunks of flywheel or an entire machine flying around. With that kind of weight and speed, it's a recipe for disaster. Though it's very rare, it's still a risk that requires careful design. And while flywheels usually take up less real estate than chemical storage, the excavation alone is pricey. So flywheels are highly effective in short bursts and overall a tidy energy storage device, but they come with their fair share of limitations. That makes it a cool but niche kind of tech, so throw it back into the steampunk curiosities pile? Not so fast. Despite these challenges, flywheels are really gaining in popularity. Let's start with the record-breaking flywheel facility currently online, the 30 megawatt Dinglun Flywheel Energy Storage Power Station, or just Dinglun for short, in Changxi, China. For context, that's much smaller than the average coal power plant's capacity, but a full 10 megawatts above the previous record holder in Stephentown, New York. The Dinglun project broke ground in July of 2023 and was connected to the grid by September of 2024, a remarkably quick turnaround. It's equipped with 120 high-speed magnetic levitation flywheels, grouped into sets of 10, with a total of 12 energy storage and frequency regulating units, forming an array that connects to the power grid at a voltage of 110 kilovolts. It's a lot of power. Now, this system is also pioneering a sort of half-buried style. Most of the tech is housed underground in a setup reminiscent of wells with windows, allowing Dinglun's operators to monitor the wells. The setup provides a safer, clearer view so workers can easily assess operations and spot maintenance needs. The point of the project is twofold. First, China is rapidly growing its green energy portfolio, and again, FESSs pair really well with wind and solar energy. It just patches over the energy shortfalls and intermittent zones of those technologies with ease. It acts like a buffer. That leads into Dinglun's second point. It's a pilot project. It's still early, but if all goes well, then we could see a lot more Dinglun scale FESSs popping up around China to help all those other renewable energy facilities. So let's look at another record-breaking flywheel. German company Siemens provided the largest single flywheel for Moneypoint station in Ireland. Moneypoint is Ireland's only coal plant, and with an output of 915 megawatt at its peak, it's the single largest power producer in Ireland and capable of providing 25% of the entire country's energy. Of course, these features also make it the single largest greenhouse gas emitter in Ireland. That's why the country is enacting a multi-phase plan to transition the station into a green energy hub, dubbed Green Atlantic at Moneypoint. And yes, the at symbol is part of the official title. Now, phase one of this plan is the massive flywheel. The rotor alone weighs over 130 tons. It's a big boy. And when combined with a smaller 66-ton synchronous rotor condenser, a close cousin of an FESS, they produce around 160 megawatt hours in the rotating mass, which can be tapped into on demand. With the flywheel up and rolling just days before 2023, Ireland's ESB has turned to phase two, the construction of a 1,400 megawatt offshore wind farm, which will be connected to the FESS. The following phases will revolve around turning the area into a wind turbine manufacturing hub, as well as the production and storage of green hydrogen. And that might give you some pause considering hydrogen's perennial status as in, any day now it's going to solve all of our problems kind of technology. But hey, at least they've installed 5 wind turbines capable of producing 17 megawatts, and the flywheel is up and running. Or should I say, up and spinning. So let's get back to the FESS festivities, but on a smaller scale. USS-based company Torus just signed a deal to supply the Gardner Group, a commercial real estate firm, with nearly 26 megawatt hours of energy storage using Torus's hybrid flywheel and battery energy storage systems, or BESS. FESS and BESS pair well because they have complementary strengths. FESS is great for short-term, reactive storage, while chemical batteries handle the longer-term stuff. Torus has also developed a proprietary software platform enabling smart energy management, demand response, and integration with renewable energy sources. Apparently, it plays well with EV charging too. It's standard smart monitoring kind of stuff perhaps, but still nice to see as we move to smarter grids and putting flywheels in more places. Torus and Gardner Group plan to begin installations of the FESS BESS systems in Q4 of 2024, aiming for completion by Q1 2026. Now, once fully operational, these systems will be able to store and dispatch nearly 26 megawatt hours of energy, approaching Dinglun scale capacity. According to Torus, that's enough to power nearly 1,000 homes for a full day. Now, the exact facilities that Torus's hybrid systems will support aren't public yet. Historically, flywheels have been great for emergency power, not just for the grid, but for energy-intensive spaces like data centers or hospitals. Gardner Group manages various commercial properties from malls and offices to tech centers, and even some residential communities by the look of it. Maybe flywheels are widening their niche a little bit. We'll have to wait and see. Let's end with a familiar face, California-based Amber Kinetics. We last checked in on them a few years ago when they debuted their all-steel M32 FESS. Back then, the company had recently deployed some FESS units to the West Boylston Municipal Lighting Plant as part of a solar array. As of 2023, the plant still mentions its flywheel assets, so I'm guessing they're still rolling. And in that case, no news is probably good news? At the time, Amber Kinetics was also teaming up with Chinese company Yunggao Renewables to support a 60 megawatt solar installation. As of 2024, that solar plant is still in operation, though I can find no mention of the flywheel system. That could be a language barrier though. Since then, Amber Kinetics has expanded further, installing flywheels in Hawaii, Taiwan, the Philippines, and beyond. These aren't massive FESS installations like Moneypoint or large arrays like Dinglun, but it's impressive to see just how many places adopted Amber Kinetics flywheel tech. Amber Kinetics is also partnering with Key Energy of Sydney, Australia to install a system at a residence in Sawyers Valley, Perth. With wildfires becoming more common, the owners wanted a system that posed no fire risk, yet offered energy security given the frequent blackouts in the area. Sounds like a job for a flywheel. Now, Key Energy has also developed a way to install Amber Kinetics flywheels above ground, avoiding the costly excavation. If they've truly found a cost-effective way and reliable approach, this could make FESS a lot more affordable. Amber Kinetics has also expressed interest in further expansion in the Philippines. Infrastructure is a challenge on this tropical island chain, though honestly it's tough to maintain anywhere. In rural parts of Mindanao, the second largest island, high electricity costs and grid unreliability are common. Installing flywheels to stabilize microgrids could make a real difference for these communities. As promising as this sounds, it's just a stated goal for now, so we'll have to wait and see if it comes to fruition. So are flywheels the ultimate solution to all our energy problems? You've watched this far, so you already know the answer, no. But they're incredibly effective for smoothing out grid fluctuations, a role that's becoming more essential as we add more renewables like wind and solar to the grid. So while flywheels may never be the star of the renewable energy storage world, they're a pragmatic supporting cast member. In the near future, I expect to see many more facilities following in the footsteps of Dinglun, Moneypoint, and others. But what do you think? Do flywheels have a spot in our energy storage arsenal? Jump in the comments and let me know. And be sure to listen to my follow-up podcast, Still to Be Determined, while I'll keep this conversation going. And thanks as always to my patrons for your continued support, and a big welcome to my new Supporter Plus member, The Nocturnist, who has a great username. Keep your mind open, stay curious, and I'll see you in the next one.